All right, this is Unit 8, Trigonometry. We're doing Day 2 trig ratios, trigonometric ratios, and there are three basic trig ratios that we're going to be talking about today. There are another three that will come up, but we're going to focus on these three basic ones today. The sine, cosine, and tangent is how these are pronounced. And I'm going to sketch a quick right triangle to help make sense of what these ratios are talking about. So for any right triangle, there's going to be two acute angles. All right. Let's say I'm talking about angle A right here. And from angle A, this leg would be the opposite leg. This bottom leg would be the adjacent leg to angle A. And you always have your hypotenuse opposite of the 90 degrees. So the sine of angle A is always equal to the ratio of the opposite side length divided by the hypotenuse. In this case, O over H. The cosine is the adjacent leg divided by the hypotenuse. In this case, A divided by H. And the tangent is the opposite leg divided by the adjacent leg. So in this case, O divided by A. Now, these are established curves that we can graph, that we can plot using our special right triangles. We're not really going to get in that in Math 2. We're just going to be using these functions to solve problems. All right, using the ratios we just expressed on the previous page, I'm going to make this little cheat. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. And what that'll allow me to do is, if I can remember that word right there, so ka'atoa, or maybe use a phrase to help me remember the order, that'll just allow me to remember what goes with sine, what goes with cosine, what goes with tangent. This is something I always write at the top of my quizzes and tests when I'm doing trigonometry. So, sine of P. If I refer to angle P, the opposite leg is 15, the hypotenuse is 17. I referred to those because sine is opposite over hypotenuse. So my answer is 15 over 17. Next, I'm going to do the tangent of P. If I refer to my little cheat here, tangent is opposite over adjacent. So if I go to P, opposite is 15. Adjacent is 8, so 15 over 8. And if I do the cosine of Q, Q is going to have an adjacent leg of 15. See, I'm referring to this. Cosine is adjacent over hypotenuse. So the adjacent leg is 15 to angle Q. The hypotenuse is 17. So 15 over 17. And that takes care of A, B, and C. You'll see that the sine of one angle will always be equal to the cosine of its complement. Now, if you want to pause it really quick to do D through F, you're welcome to, and I'll pick that up in just a moment. And with the cosine of P, cosine is adjacent over hypotenuse, so when I refer to angle P, adjacent is 8, hypotenuse is 17. Some people will say, well, isn't 17 also adjacent to P? But it's not the adjacent leg, which is what I'm talking about when I say adjacent. 17 is the hypotenuse here. Sine of Q, sine is opposite over hypotenuse, so opposite of Q is 8 over, hypotenuse is 17. And tangent of Q, tangent is opposite over adjacent, according to my little cheat over here. So opposite is 8, adjacent is 15, 8 over 15. And you can see that the tangent of an angle will always be the reciprocal of the tangent of its complement. 15 over 8 became 8 over 15. That's because you're flip-flopping where is adjacent and what is hypotenuse. Now what I'm going to do is actually apply these ratios to actually solve a problem. You can see that X is missing and what we're after. We cannot use Pythagorean theorem here since we're missing the bottom leg. Have no idea what it is, nor is this a special right triangle since this is 70 degrees out here. I'm going to have to rely on sine, cosine, tangent. So I'm going to write out my list and figure out which of the three functions I'm going to use. For any given problem, you're only going to use one of them. As I'm looking at the 70 degrees, you always go off of an acute angle. You never work off the right angle. So looking at the acute angle, The two sides that are involved on this problem is the adjacent leg and the hypotenuse. The opposite side is not involved. So since it's the adjacent leg and the hypotenuse, I see that it has to be the cosine function is what I'm going to use. The other two functions both use the opposite leg, which I don't have here. So it's going to be cosine. So I'm going to set this up. Cosine of my angle equals a ratio. The cosine will always be of your acute angle, in this case 70 degrees. Now, it needs to be adjacent divided by hypotenuse, so it's going to be x over 15. Now, you might not feel too comfortable about this, but the good news is you can actually type that in your calculator. There's a cosine key on it, and I'll show that in just a moment. But I'm going to go ahead and solve for x real quick by multiplying both sides by 15. So x is equal to exactly 15 times the cosine of 70 degrees. All right, now we're going to use our calculator. All right, I had to erase that page so you could see my calculator here. First thing that I'm going to do is actually check the mode of my calculator. We were operating with degrees, and your calculator does not default to that. So if you'll click the mode key, which is right here beside second, you'll need to select a degree instead of radian. It defaults to radian. You need to have it on degree. Once I've actually highlighted it by hitting enter on degree, I'm ready to go with the problem now. And if hopefully you wrote it down, that my answer was 15 times the cosine of 70 degrees. When I type that in, it does cosine of 70 and it multiplies it by 15, and I get 5.13 for x. So now I'm ready to answer. X is approximately 5.13. And that is to the nearest hundredth. That's the problem asked. All right, ready for this next example. We're still missing a side, so I'm going to write down my little reference here. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent's opposite over adjacent. What's going to happen with that is, looking at the acute angle, 25 degrees, I do have an opposite leg, and 18 is the adjacent leg. What's not involved is the hypotenuse. Since the hypotenuse is not involved, it's not going to be sine, it's not going to be cosine. Opposite and adjacent means I'm going to be using the tangent function. So it'll be the tangent of my angle equals my ratio of opposite over adjacent. Let me get this fixed where I kind of wrote that a little too high. All right, so the angle that I'm using is 25 degrees. Now you got to be careful here on whether it's x over 18 or 18 over x. Sometimes the 18 will be on the numerator. So with 25 degrees here, x is my opposite leg. That needs to go on the numerator. So it's going to be x over 18. To solve this one, pretty easy step. You just multiply by 18 on both sides. So x is equal to 18 times the tangent of 25. That's it exactly. Now I'm going to type it in my calculator to get an approximate answer. So I'll go ahead and do that now. (18) times the tangent of 25. If I don't hit the times key, it automatically multiplies. So 8.39 is my answer to the nearest hundredth. And that's really typical for you to answer to the nearest hundredth on these. Hopefully you're getting kind of a feel for how these go. On this problem, I'm going to do it again, writing out my little cheat. So if you're going to do that on every problem, you're actually going to get really used to actually writing that out. With this problem, the side that's not involved on the problem is the opposite side. 100 is adjacent to the 23 degrees and x is hypotenuse. So I'm going to be using cosine on this problem. The cosine will be of 23 degrees, and it will equal adjacent over hypotenuse. This one is actually going to have the number on the numerator, 100 over x, the hypotenuse. Now, some people might panic on a problem like this. It's actually really easy if you just first multiply both sides by x. So it'll be x times the cosine of 23 equals 100. Now all you got to do is divide by the cosine of 23. All right, so x is equal to 100 over the cosine of 23. And all I've got to do is just type that in my calculator. Good news is with your calculator, once you've changed it into degree, it's going to stay there unless the calculator gets reset. So it's really a good habit to actually check that at the beginning of every session that you do. So now I'm going to type in 100 divided by the cosine of 23. I had a little typo there, excuse me. 100 divided by cosine of 23. There we go. It's 108.64. Please be sure you round correctly. If this 100th place should be rounded up, please do so. All right, now we're going to change gears and actually calculate an angle. This is going to be kind of a strange thing. In different maths, depending on what textbook you're using or whatever, they're actually going to use different notations with this. Now, fortunately enough, in Math 2, we use one standard notation for this, so you're not going to get caught off guard, but just keep in mind that when you go on the pre-calculus, perhaps, you're going to see this represented a different way. Let's go ahead and get the setup because that is the same. So I'm going to figure out the measure of angle A. First thing I do is write down my little cheat that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent's opposite over adjacent. Now, looking at angle A, the top angle, I'm going to look at the sides that they provided me. They provided me with 18, which is the opposite leg. They provided me with 27, which is the hypotenuse. Opposite and hypotenuse is what I've been provided with. I'm going to be using the sine function is what I'm going to use. So I'm going to set this up, sine of my angle, which by the way I do not know, equals my ratio. Now, I do not know the measure of angle A. I'm going to write it in right here. Sometimes they'll use an X to represent that unknown angle. Now for my ratio, it's opposite divided by hypotenuse, so is 18 divided by 27. Now you could reduce that to 2/3 if you like. What I'm now going to do is solve for the measure of angle A. Now, how in the world do you get the sine function to the other side of the equation? It's actually a step that I rarely completely write out, but you're actually doing the sine inverse on both sides. So it'll be the sine inverse on that side and the sine inverse on the right side. And that's sine to the -1 power. All right, rarely do I write that step out. I actually usually just jump straight to where it cancels on the left-hand side to just the measure of angle A. And it equals the sine inverse of 18 over 27. And now you're ready to use your calculator. And I'll show you where to find that operation right now. What you do is you actually just have to hit the second key. Second, sine inverse. It's in blue on the sine key of 18 over 27. And close my parentheses. All right, and I get 41.8 degrees. I do believe it said to the nearest tenth, so that's my answer, 41.8 degrees. And I am going to say that I approximated that with the squiggly equal sign that I've been using today. There we go. We found the measure of angle A using two sides of a triangle. All right, my last problem for today is just one more of those. Find the measure of angle A, that angle right there. Looking at sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent's opposite over adjacent. Yeah, I've said that a lot on this video for a purpose. It's to try to get it into your head. All right, so looking at angle A, I have the opposite leg and I have the adjacent leg. The hypotenuse is not involved, so I'm using tangent on this problem. The tangent will be of the angle, which I do not know, measure of angle A, equals, and it needs to be opposite divided by adjacent, so I'm actually going to have the 6 divided by the 20. Again, to solve for the measure of angle A, I will use the tangent inverse. And that is on the tangent key on your calculator. You just have to hit second before you actually type it in. So now I'm ready to type that in. X is equal to the tangent inverse, so second tan inverse. Again, I'm hitting that second key, then hitting tangent. of 6 over 20. Some people like to reduce that fraction first. It's fine if you don't. It'll be okay. And I'll get 16.7 degrees. I'm going to round to the nearest tenth just like I did on the previous problem. Just work off what the instructions say. If they want to the nearest hundredth, this would be 16.70. If they wanted to the nearest tenth, it'd be 16.7. All right, and that wraps up today. Go ahead and do the assignment that goes with this lesson, and let me know if you got any questions about it. Thanks.